Okay, we continue now by moving to talking about ordinal measures of association. So, with the ones that we have done so far, at least one of the variables had to be nominal level. But there are some additional statistics, measures of association statistics that we can use that allow us to run calculations on ordinal level variables. And so the idea of this is that we talk about ordered pairs. As you have things that are going up or down in level when you have variables that are operationalized at the ordinal level. And these are essential for the calculation of gamma and Summers D, which are the last two statistics that we'll talk about in today's lecture material. Gamma, like lambda, is a PRE measure, and it is based on ordered pairs used with two ordinal variables. So lambda, you had to have at least one nominal. You could have had an ordinal level for the other variable. But for gamma, you have to have two ordinal variables. And it's symmetric. What that means is that it doesn't distinguish between independent and dependent variables. So it's just the row variable and the column variable. You don't have to have variables that are where one is identified as independent or dependent. So it doesn't tell you about direction. I mean, it doesn't tell you about which one is causing the other. So it just doesn't distinguish there. The formula for calculating gamma, and that's the wrong symbol. This is not gamma. I don't know why it came out as an A, but I'll show you what gamma looks like in a minute, is S minus O over S plus O. So S stands for same direction pairs, or what we call concordant pairs, and O stands for opposite direction pairs. I think gamma is the most difficult to understand of the statistics, and we're going to take a little time to run through an example, and I have a number of slides that carry us piece at a time through the process of calculating gamma and identifying what are concordant and what are discordant pairs. Gamma is the most frequently used PRE measure for ordinal level measures. It's one of the few that we have in our toolbox for ordinal level measures when we're not pushing it to interval ratio level and pretending like those categorizations are equivalent to numeric categories, to actual numbers. Rather than using the marginal totals, which we have been using, those row totals and those column totals as part of our calculation, gamma uses the frequencies from within the table to calculate the association. The results that we get are from -1 to +1, where 0 means that there's no relationship between the variables. -1 means that there's a perfect negative relationship, and +1 would mean that there's a perfect positive relationship. And gamma, the logic of gamma helps us to kind of make that transition next week to correlation, which is what we'll talk about for March 30th. The guidelines for interpreting the strength of a relationship with gamma: 0 to 0.24, we define as having no relationship; 0.25 to 0.49, a weak relationship; 0.5 to 0.74, moderate; and then 0.75 to 1 is a strong relationship, regardless of whether it's positive or negative. We use those same terms. Whether something is the strength of the relationship doesn't have anything to do with the positive or negative direction. So a positive 0.35 would be a weak positive relationship, and a negative 0.35 would be a weak negative relationship. So this example, I believe that this table comes from your book. So it is burnout by length of service for teachers. So we have along the top, we have the length of service: low service or short period of time, moderate, and high length of service. And then down through our rows, we have our burnout levels: low level, moderate level, and high level burnout. Now, look at the way this table is organized. The matching pairs, right? These concordant pairs, this is our low, low, moderate, moderate. So you have the same level intersecting. So that's kind of when we're talking about those concordant pairs. Those are those ones that match up or are going in the same direction together. So we have a total of 100 teachers that we have matched. We have asked them the questions about how long they have been serving and their length of burnout. And so we'll use this example throughout this exercise. So concordant pairs are all those variables or all those values within the table that are below and to the right of each cell. So if we have low, low here, this is our cell. And we're going to talk about the cells as um, within and all the ones that sort of come out from it, like almost like a tree coming out from each one. So we have 20 teachers who identified as having low level of length of service and low burnout level. So that value goes in here for calculating our concordant pair. And then all of those that are above it in the table on both dimensions. So none of the things that are low are included. They're not shaded. So we have 20 times, and then we're going to sum these concordant pairs, and we end up with 20 multiplied by 15. Okay. Plus 5 plus 11 plus 21. So our value for NS for this particular cell, and we're going to do it for each cell on the table, is 1040. And then we're going to add those values together. So we're going to sum all of our concordant pairs, and then we're going to calculate and sum all of our discordant pairs. So for LM, for low length of service, moderate burnout, we have this cell here, 10. So that value goes down here. And then we're going to multiply that by the sum of the concordant cells. So we have 11 and 21 because they are higher in both dimensions than the cell that we're looking at. So for this cell, the concordant total is 320. So now we are dealing with low length of service and high burnout. And so if you see, this is our highlighted cell. There's nobody above it. These are our total rows. Those don't get included. So this cell is by itself. So it would be 8 times 0, or 8. And we're going to continue to do this for all of our cells in the table. For moderate length of service and low burnout, we have our value of 6 for that cell. And then the cells that are bigger in both dimensions are 5 and 21 for our high moderate and our high high. So those will go in there, and you would get 156. For medium, medium, or moderate, moderate, there's this one cell that is higher in both dimensions. So 15 times 21, or 315. We go to our moderate high. We have a value of 11. There's nothing to multiply it by, so the value is 0 because there's nothing higher in both dimensions. For high, for all of our highs here, we're going to have zeros because there's nothing to the right and below that cell that we can multiply it by because we don't include those totals. So for high medium, we have this cell that has 5 in it, but there's nothing higher than it in both dimensions, so that value is 0. And for high, we have that is the value is 21. So when we add all of those numbers together, we get 1831. So what are our values that we're adding together? I'm going to scroll back up. So we have 1040 plus 320 plus 0 plus 156 plus 315 plus 0, and then zeros for all of those. So our total is 1,831. So that's our value for NS that will go into our formula in a minute. Now we have to calculate ND, or what are called discordant pairs. And those are the values that are below and left of each cell. So now we're going to start with our high length of service and low burnout, and we're going to go down and to the left. So we're going to take our value of 4, and we're going to multiply it by the sum of all of those cells, the frequencies in all of those cells that are below and to the left. So for this cell here, it is 176. We do the same calculation for high, moderate. Down and to the left, we have 8 and 11. So our value is 108. Here we have 21. There's nothing down and to the left of it. Our moderate low, we have 6, and these two values down below and to the left. 15, we have the value of 8 that is down and to the left of it. And we continue the process. And when we get to our low lows, we're going to have our sets of zeros again. And the total for the discordant pairs is 499. So now we are going to take this is the formula on the left here. This is the one that the textbook shows you. This is the one that I think makes it a little bit easier. So instead of S and O, I have N sub S and N sub D. And this is the formula that I am accustomed to using. So we have 1831, that's our concordant pair, minus 499, which is our sum of our discordant pairs. And then on the bottom, we have those added together. So 1831 plus 499. And we end up with 0.57. So we have a PRE of 0.57 for the calculation of gamma. We can also state that there is a moderate positive relationship based on our criteria that we had above, our little chart on how to interpret it, between length of service and burnout among teachers. When you run gamma on SPSS, it will give you a statistical significance as well. So I won't worry about showing you right now, but we can interpret gamma by saying that we have 57% fewer errors if we predict the order of cases on one variable from the order of pairs of cases on the other. So it's the same kind of thing. How does having that information about that second variable help us to predict that first variable? So it's the same kind of measure that we were talking about with lambda, but it's something that we can do with ordinal level variables.
Did you finish with that one?
Yes.